Is it possible to even prevent a massive supervolcano eruption? If you're dumping more water into the ocean from ice, is it going to be better?
We cannot evacuate cities in time.
And it's like a catastrophe on a massive scale.
You change the mean global temperature, or you can just set the sea level, like raise it 1 meter. The fundamental problem with humanity is...
And I'm assuming that's affecting the world quite a bit right now.
Russia, right? There's still a bunch of landmass up in the Arctic. How fast is this glacier flowing? Why is it flowing this way?
Hello and welcome to the 3D Media Live podcast. And I have a wonderful guest today, Samuel Herod. Welcome to the show.
Thank you so much.
Samuel is a good friend of mine, and he has a PhD in glaciology and has very interesting things to share with the world. And without further ado, let's jump right into it.
Love it.
So tell me, how did you get into glaciology?
I grew up in Alaska from into first grade, second grade through undergrad. So I just grew up in this mountainous environment and grew up relatively poor. So I didn't really explore the state that I grew up in. And then in my 20s, I started to aggressively explore this place. Alaska, especially where I grew up in Fairbanks, it's like more like an Arctic trailer park, which has good utility if you use it, which is you're at the hub of adventure and wilderness. But if you don't, you just stay in the town, then you're missing out. So in my 20s, I aggressively caught up in terms of running and climbing and exploring. And in the process, I was just in this wild, massive landscape. And I was just coincidentally climbing with some Jews from New York City and also scientists. And they taught me how to see the world in questions. And everything changes when you see the world in questions. A rock becomes interesting. A mountain becomes interesting. Why is it there? What's happening? How fast is this glacier flowing? Why is it flowing this way? Why doesn't it exist over here? Why do we have to drive 3 hours to go climbing? Why don't we drive 10 minutes to go climbing? Like all these questions. And to start to address them, this was kind of you're drawn in by the vast beauty of the Alaskan expanse. And then these questions brought me into the laboratory. It got me into math and physics, writing code. And then answering these questions became a PhD.
So like you mentioned writing code. How does that relate to glaciology?
So, I mean, yeah, like the people see the pictures of the lifestyle and they think, wow, I'm so envious of the life you live. And the reality is if you like being outdoors, just work a normal job and pay your cash to go out in the mountains and appreciate them recreationally. Because when you're professionally working in the mountains, it's not fun. You especially in geophysics, a geologist goes and takes rocks out. It's pretty simple. Take some measurements in the field, but in geophysics you have batteries, car batteries, like electronics, very expensive equipment that you're actively collecting measurements. You're sending radar signals. You're taking thermal images. You're using GPS, high precision GPS. It's all very intensive to use these energy intensive equipment in the middle in one of the roughest environments on the planet.
Like how is coding involved with glaciology?
Right. So what I'm saying is that the glamour pulls you in, but then once you're hooked, you realize that you spend maybe a few percentages of your career actually out in these beautiful places, taking these pictures. You're actually sitting at home writing software to process these nice data that you've collected. And so, this is the fundamental question. And I've taught high school classes on this, which is kind of a fun topic, which is how exactly do you go into an environment and take numbers, take information out of it? Like to go and measure a mountain is not so simple, right?
Right.
And so we have to quantify the planet if we're interested in knowing how it's changing, and how you go there and you bring back numbers, bring back information. It's not so simple. And so what you end up doing is you collect you bring the sensors, what you have, there's some clever methods to get as much information as you can with as few sensors as possible. And then you're doing something that no one's done before. So there's no app, there's no ready-made package for you. So you end up having to write your own software to process this data, to understand it.
Oh, wow.
And then you publish it. and more it used to be pretty hacky. You could get by with kind of rudimentary code to just process your data, make some figures. But now these modern journals, they want your code, they want it to be reproducible. They don't you used to say in the acknowledgments of an article, say, oh yeah, you can contact the author if you want to get the data or see the code. Now they want it to be functional. You want it to be in Jupyter notebooks where you can just run the code and reproduce the plots. Which is beautiful. It's a great thing for science, but it's made us all become better programmers.
Like in my mind, glaciology is something where you just go observe, you touch. Coding is not. I don't think most people realize that there's coding involved, and you have to process lots of numbers. How was glaciology before computers?
Yeah, and
How old is this field?
Yeah, probably like the 40s. I mean, like the turn of the century, the first measurements were first like geographers, exploration. People were doing exploration. Like in Europe and Switzerland, people were starting to. There's more infrastructure around the European Alps. This is where it all began, really. But then, especially Alaska, it was like 1910. The first boats came up, and the Northwest Passage taking pictures of the icy bay and the tidewater glaciers, and people starting to just draw hand maps and then Brad Washburn was this pioneering. He came from Boston, and he would come and fly and make topographic maps. So, but there was certainly a golden era of glaciology where it was a bit more the explorer who just happened to be a bit clever and willing to carry some instruments or take some notes or draw some pictures. Like that, those early articles they're written very poetically in this kind of old-fashioned style, and it was a different world. But now it's really transitioned to math and physics and programming and data science. We've all become data scientists.
What is glaciology at the root of it? What is the purpose of it?
Well, fundamentally, we have two. It's quite incredible that our planet has. If you just spin the globe, you see a lot of blue, a lot of green, some red, and some deserts, and then you have these two big white patches. It's kind of wild. Like, look at northern Canada, right? It's a landmass, and it's pretty deglaciated. It's just mostly islands, up northern islands. And then you just turn the globe. It's a tiny little bit, and you have this solid chunk of ice, Greenland, this like kilometers thick ice sheet. Why? How come one here is an ice sheet and one right next door? You got nothing. Keep going around Russia, right? There's still a bunch of landmass up in the Arctic, and you don't have some little glaciers on Nova Zim. I don't know the names. You do better, maybe. And it's just wild. But so we live in an interesting time where we have everything. We have massive deserts, like almost unlivable deserts, and we have perfect, like Southern California, like perfect environment for the human skin. Like we have a very narrow window of comfort, and nothing offends us here. It's beautiful. Not so many places like that. And then you have these ice sheets like Antarctica and Greenland, and then it's wild that they exist. And so the question of glaciology is, number one, what's this ice doing? How is it moving? Like it's like what defines a glacier is that it's under the weight of itself, it's internally deforming and flowing. So it's behaving a bit like a river of ice, so to speak. Very slow, but it has the similar properties. And so just understanding how they flow and just their mass balance. So they're gaining mass on the upper reaches. Like just fundamentally, a glacier is just snow that compacts. The density goes from fluffy snow, becomes firn, which is a bit more dense, to ice, which is it's kind of like a metamorphosis to this solid phase, yeah. And then it just accumulates to the point where under its own weight, it'll flow and through gravity be transported down glacier or down slope. And so it basically transports ice to a climate where that climate would not otherwise support ice. So you have these tongues of ice coming down from mountain ranges because it's accumulating and it's flowing. And it's just number one, it's an interesting water resource. There's places in especially South America where the glaciers have been a historical, very important water resource. Also in the Himalaya, they're a bit of a hazard. There's certain floods and landslides and things that are associated with glaciers that if you have infrastructure near them, then this is worth understanding. And then there's just the simple, you take water molecules that are trapped on land and you change phase from solid to liquid, and they will transport down into the ocean. And then if this is not being resupplied as snow and again fueling the glaciers, then you're just having a sea level rise. So there's this some effect of all the glaciers on the planet that are raising we call it eustatic sea level rise. We have thermal expansion and other factors that are creating sea level rise, but this is just like literally saying water molecules that weren't in the ocean previously are coming into the ocean now.
And I'm assuming that's affecting the world quite a bit right now, and more so than it used to.
This is the main probably motivator for our proposals is sea level rise. Yes.
How is that going to affect us in like the next 10, 15, 20 years?
So the problem with the main fundamental problem with humanity is we're not very nomadic. We like to build big cities, and we like to build them where it's convenient.
Right on the coast.
We really like water. We really like growing things. We like floodplains. It's kind of problematic. So we've put a lot of infrastructure in places that are quite vulnerable. And so the problem is that the timescale of this change is not really something our brains are very well wired to function on. These hundreds of years timescales. Like our brains are more like, where's the food today, than like, whoa, what's the impact down the road? Like when we were exploring for oil and gas, we're like, this is unbelievable. We have this resource, we can do everything, and then we have these knock-on effects, and we kind of have to correct. And so, for the changes you'll see, well, I think the biggest worry that we are facing is climate refugees, people in poor countries, rich countries across the world who are living in these low elevation communities, and you'll first get it in storm surges. You'll have when you have the bulk sea level rise is still, it might not be at your doorstep, but then a more moderate storm will bring water further inland if the whole ocean is a little bit higher, and then in some point you will raise to the point where you'll see entire cities that are evacuated.
Wow. At what point?
A lot of the modeling we do is to 2100. It was sort of picked just at I think it was the first IPCC where they just needed to have like a modeling target. So if people were running forward models, it says, look, it would really help if we were kind of unified on this. Like, let's all just try to run to 2100. And it was kind of this idea where it was deep enough in the future that we were really measuring change, but it's not so deep in the future that the error bars just explode, and we're not really able to constrain the problem. Arguably, it could have been pushed a little further. It might have been more interesting, but it's true that the deeper in time that you model, the wider your error bars get. So we just wanted.
But I'm curious, like more confident. In my lifetime, how is that going to affect us?
Do you own coastal property?
How far is the water going to rise?
There's some really
20
nice.
years.
Yeah, there's some good online maps where you can do this. You can. It's either you change the mean global temperature, or you can just set the sea level, like raise it 1 meter, raise it 50 centimeters, and just see what happens. See who's flooded. But it's a little bit misleading because, right? So even though it's maybe not like lapping at your door, storm surges and things will become much more devastating. And so the kind of the place where you can look, there's not too many people that are really concerned on this timescale. It's like climate scientists for sure. We're all bought into it. Politicians less so, right? Like it's the cycle of politics is
immediate
not quite.
Yeah.
It's like obviously for very progressive minded people, they're willing to take sacrifices now for 100 years from now. But it's like that's a real luxury to be able to do this. But other people who are concerned are like reinsurance companies. So they're massive companies that insure insurers, and so they're thinking on these timescales, and they're thinking like, look, like if,
I never thought about that. The insurance companies are seeing further ahead than anybody else.
The reinsurance, right? Because like a few insurance, like a whole company could fail, no problem. Like their company's fine, but if every coastal real estate if like coastal real estate up in the entire eastern seaboard collapses, and then everyone's filing insurance claims, every insurance company goes under, then reinsurance companies.
What's a reinsurance company?
They're basically, so a small like a normal insurance company, they're like they're taking on some amount of risk. Everyone buys in, and the hope is that a certain percentage will never make a claim, and the people that do make a claim, you can cover them, no problem, right? This is the fundamental concept. And then so reinsurance is just one step removed from that. They're insuring the insurers, so it's even just much bigger masses of money. But it's, again, like if you're insuring lots and lots of different little like elements, right? Then some can fail, and this is still a functioning
they're thinking on
system.
Completely different scale.
Exactly.
Wow.
But they're taking climate change very seriously. It's not a political issue for them.
That's a fiscal issue.
It's a fiscal issue. 100%.
Wow. And so, like a lot of people are saying, global warming isn't real. The rising seas are not real. So if they're taking it that seriously, it has to be more or less real. It's not a political issue at all.
No.
Yeah, and I mean, I don't think people realize that at all. Nobody's really thinking it through that it's going to affect them personally, especially along the coast and stuff. I mean, it's going to dramatically impact society if we're all of a sudden going to have less land and people have to relocate. And it's like a catastrophe on a massive scale.
Yeah.
How massive is this going to be? How massive of a catastrophe? And how do people... And actually, you know what, just a thought off the path a little bit here. You know, today's politicians, like you mentioned, they're thinking in terms of being reelected. What if we have AI guiding us in more like much wider time spans, thinking 100 moves ahead? Then I think it's going to change the game entirely. I even started thinking about it. What if people will try to elect AI to govern?
Yeah.
Do you think that's a possibility?
In terms of handling a multivariate optimization scheme, which is basically what you're doing as a politician. You're taking in as much information as you can on issues and poskening, right? Like, this is fundamentally what you're doing. And the problems are probably too complex for
any human
anyone,
Yeah.
even with a very clever cabinet, whatever. I think they're very, like, to make it, and that's the thing, is you're making choices on many different scales. And so the choices that we make that may be good today could be disastrous tomorrow. And I think clever AI could balance those risks much better than any person could. I think we would all be a little bit, we might be very vulnerable to see what those choices are if such a AI was making them. I think it could put us all in a vulnerable situation.
Well, let's say, you knowing what you know now as a scientist in this field, you're set to govern. What would you do? What would you change? What kind of laws would you pass?
Good question. I think it would just be like the problem is that it's a global problem, right? And a lot of Americans, I hear this, if you get on an airplane and you talk to the person next to you, like, a very repetitive trope that I hear. It's like, well, why should we do it if China's emitting more and causing more of the wedge of the problem, and they're doing less? Then why should we? And I think the answer to that is we need someone to innovate. Our country is very successful at innovation, and you can sort of lead by example. And so these changes need to be like these, the Kyoto Protocol, the Paris Conference. Like, I think these are so critical to sort of just take the time to do the very, very nuanced
Approach.
Yeah. I mean, nuanced diplomacy between, like, finding out what countries what they can do, what bigger countries are willing to do, like, to just kind of be very gentle but kind of direct. Like, we need to lower the global mean temperature. We need to reduce our
And how
emissions.
do we do that? Just the emissions. That's what's causing it mostly.
Right. So this is our biggest contributor as human beings. This is how we're affecting the planet the most.
How much are we actually affecting on, like, let's say, percentage scale? Are we contributing 3% to global warming and rising sea rise?
Ask our AI for this precise. But what I do know is that there's feedback loops, right? So if you a big component is if you have energy coming in from the sun, and it's coming in, a lot of it's hitting, say, it's hitting either the southern hemisphere or the North Pole because of the tilt of the Earth. So it's either getting more direct, like right, the sun doesn't set in the poles, right? And so a lot of this energy is hitting either the Arctic or the Antarctic, and it's like the white surface is reflecting the energy back to outer space. It's called the albedo. So it's just like if you're wearing a white shirt versus a dark shirt on a hot summer day, you'll be cooler in your white shirt.
Right.
Or if you buy a white car in Southern California, right?
The black's absorbing,
So
and
it's-
the white's reflecting.
Exactly. And on a global scale, this is happening. And so if we warm the planet some amount, then it shrinks the ice mass. And when we shrink, or we have less sea ice in the Arctic, that means the percentage of energy that we're able to push back to outer space is less, and it's being absorbed into the ocean. And then for a
So
lot,
it's not a linear change. It becomes almost like exponential. The more ice melts, the worse it gets. It's
almost nothing in nature is linear. So if it's definitely a nonlinear process. Whether it's like an exponential, like it's like there's many competing factors, and so but what there's a lot of these negative feedback loops, and this basically you start one system and you're just going to push another one, and then there's these tipping points that we don't really have too well constrained, like when the ocean current is just like this slow churning engine of a lot of systems. If this is this is the Younger Dryas in a way, like, right, this is the hypothesis of what causes this rapid change in climate. So things have happened before historically.
and more naturally. I mean,
Yeah,
all natural.
I mean, that's the thing that also is important.
or from meteorite striking Earth.
Or a supervolcano. These things.
Supervolcano.
Yeah, there's
But
rapid.
somewhat without human involvement. But now we're actually causing this to happen.
Right. This is kind of like a kind of when I'm speaking with people, I try to be really sensitive, and when they're asking me about the human component, I take the question very seriously, and I always start with saying that the world is not experiencing anything unprecedented right now. Like, we've certainly been in a warmer phase where there's no glaciers at all, and we've also been in a cooler phase where there's glaciers from pole to pole, and the whole thing is snowball Earth, they call. And there's been more atmospheric carbon, and there's been less. So we're not doing anything that hasn't been experienced. The only real difference is the rate, and the rate that we're actively contributing to. But in terms of the effect, like, it's here nor there for the planet. There's mechanisms in place to pull carbon out of the atmosphere, just in weathering of rocks, and it's on like 1 million years time scale. And so for us, for our security and safety and infrastructure and investments, like, this is really the concern. Just simply that we, without really thinking too much about it, transitioned into not very nomadic creatures that couldn't just pick up Louisiana instead of trying to build levee systems. We just say, let's just move it inland a little bit. Like, we can't do it. And so what it pushes us to do, which is a real pity, but there's no other way. I can't think of any other way. As a scientist, I spend all the time thinking about, like, doomsday predicting, like, seeing what's possible. I think there's no way forward other than having a reactive rather than proactive approach. Like, we cannot evacuate cities in time with like the right amount of confidence. There will be a catastrophe. A lot of people will suffer, and then we'll slowly, iteratively adjust how we are, where we are, how we do things.
Not in a preventative manner.
I think the preventative actions we'll take are insufficient. And I think there's
Unless
even the most
AI
progressive
comes in.
even with the AI, even with the most progressive politicians, I think you still wouldn't. It's too big. It's too hard. It's like it's a crazy problem. I don't know how you do it.
So then why even be concerned with lowering emissions? If it's going to happen, are we just going to slow it down? How much can we actually affect or prevent this?
Yeah, there's the papers that come out. The headlines are getting less optimistic, but there's still like this. If we are aggressive, they always give the scenarios, right? There's like, if we do nothing, if we do moderate, if we aggressive, and even the aggressive scenarios are still starting to get not so desirable. And I think this is kind of why we wouldn't intro with this, but this is why I've working not only in glaciology, studying this planet, but also working in natural hydrogen as an alternative energy source, because I just kind of got a little depressed only learning about what can happen, what will happen, modeling these, like making these predictions, and then having actual solutions to the problem. And so, like, decarbonizing our energy I think it's something we should absolutely invest our time and effort in. And the technology that we will develop in the next 100 years, it could be, geoengineering projects and things too. Right now they seem a little bit fantastical, putting aerosols in the upper atmosphere or putting up mirrors and things like this. It's not so unheard of. It's not so unreasonable to think that we can build the thermostat on the planet. But
let's actually talk about some of these solutions. Let's say, first of all, you're saying switching from carbon-based fuels to more renewable stuff.
Yeah.
Right. And you mentioned hydrogen. You're working on a hydrogen project. What is that?
Yeah, so I'm part of a startup based in France. We're a young company, but we're just looking for these really subtle surface features that have been correlated with subsurface reservoirs of naturally occurring hydrogen gas. So we know that there's hydrogen. There's like a flux of it coming out of the whole planet. But we didn't really know until fairly recently that in some areas it's being trapped, and it's mineable, and it can be productive. And so we just don't know.
How do you mine it?
Ooh, that's a good question. I think a lot of the existing infrastructure, I think, can be repurposed.
So it's just in the form of gas escaping Earth?
Yeah, but like with a rock layer that's impermeable. So right now, if you want to trap hydrogen, just like if you're producing it, they'll use like salt traps and things. They'll just put some layer that doesn't allow those, even though it's just like this very light gas, it's able to trap it. And we now think that this is happening naturally. And so,
how much is there?
I heard a stat from USGS that if we can develop 1% of Earth's naturally occurring hydrogen, it will be profitable, massively profitable.
Like 1%, what would compare to, let's say, oil? How much oil we have?
Yeah, it's a good question. I don't know.
And how does it compare in like in consumption, like energy per? I don't know, pound mined.
Good question.
How do you even measure hydrogen?
Yeah.
Is it measured in pounds?
So the main project that we're focused on, so I don't know the real intricacies of how it further down the chain, but what we're really just interested in is trying to locate where it's occurring. So
where is it occurring now?
This is where I'm comfortable. This is what I'm able to talk about. Where is it occurring now? There's a couple of spots in South America, in Mali, in Canada, possibly in the Carolina Bays in U.S. East Coast. And so there's been some instances where there's a nice article in Science magazine that actually not peer reviewed, but it's an article that discusses the state of what we know about it. And it's not too much. There's maybe like 20 known locations where we find these high concentrations of subsurface hydrogen. But what makes it so exciting, and this is where our company comes in, is that it also seems to correlate with these little, like, very subtle surface features. So oil and gas, there's really no expression at the surface where you would find oil and gas in the subsurface. You would have to look at the geology carefully and then just drill and do exploration. So it's challenging, and you need permits, and it's all these things. But with hydrogen, we think that these surface features, they're kind of like these maybe like 1 kilometer diameter circle, like sphericals. We call them circular depressions. They usually have a rim and a bit of a depression.
Depression in a rock or in earth.
So yeah, like usually like a sedimentary soil. Like we find them a lot in farmlands. So places that are good for farming are often good for developing these features. And there's a pretty strong correlation between subsurface hydrogen and their development. And so we have used AI tools to basically take the entire planet and say, look, let's just look everywhere. And we scan it with deep learning models, object detection, and then we try and pinpoint where exactly we think that these features have enough in common with those that we know are associated, so that we can try and understand where would be best to try and develop or then explore on the ground for hydrogen.
Which AI model to use?
We're using YOLO.
And it's just for scientific research mostly?
It's used for like you could detect like cars and things. It's just object detection. So it's a little the element that makes it a little more challenging is doing it geographically, and the data involved for a global scale problem is massive, right? Like so. So
you just basically upload a bunch of images and set parameters what to look for.
Yeah, we build a training data set. So where it's true positive hydrogen, it's a very sparse data set. But these features, these like semicircular depressions, they're actually ubiquitous. They're all over the planet. And so we train on just the features themselves, and then we analyze their geomorphology, their shapes and the geometries of how they express and their patterns and things. And then we try to correlate them with what we do know, this sparse data set. And then a part of it, we've already begun this in France to go and just start taking samples of like maybe a meter depth to try and see if we can get a signal of hydrogen.
Just thinking out loud here, what would happen if you take that language? I mean, if you take that AI model and plug it into a language model, and you allow them both to kind of take both functions together, and maybe you train the language model to find a way through all the human articles. What are the solutions? And then use this technology to find out. You know what I mean? Somebody had to come up with a data set that this is useful to look for hydrogen. What if there's other elements or other resources we haven't even thought about discovering? And then most likely there would be a language model that kind of thinks about those kind of things because it has all the vast knowledge already, all the resources, all the published studies, and then it comes up with novel ideas, and then it takes another model that's able to look at images and process that. Has anybody ever done that?
It's not clear, like the pace of when these sorts of ideas will be possible. When the AI is clever enough to conduct its own tests and basically not just replace the programmer exactly, but also replace the PI. I think it's not inconceivable. It's probably coming much faster than we think. I don't see why an AI model couldn't come up with the same ideas that I can.
That's I think where we're heading. Maybe at 10, 20 years, I think it's going to drastically change the whole field of expertise is going to be very different. Right now, we're depending on human knowledge, on your research, on every scientist out there. But in 10, 20 years, I mean, it's already probably AI has more knowledge than you in some ways. Might not be able to rationalize that knowledge or how to apply it. But in 10, 20 years, that's... So have you ever thought about that? Like, how is your field, how is your research going to change if that happens?
I mean, the real question is, what field would I encourage my child to pursue?
Right.
To not be obsolete, right?
Exactly.
Right now, the software engineers are doing very well, but this could be very short-lived.
Even that would be, I think, completely obsolete.
Completely obsolete, yeah. I mean, right now, I mean, you can, you can have no coding experience. It's almost a bit like, I think for a while, it's be a bit like the iPhone, right? Like even any dope can now take a very excellent photograph, but still a professional photographer can frame and take with a nice camera an arguably better picture than an iPhone.
I'm gonna switch to iPhone soon,
but it's close, right?
I'm already. I think in this field, I think a lot of people have switched.
Yeah. Wow.
To using iPhones for filming and maybe not photography yet, but filming surely. It's the AI. Built into processing images, putting all multiple layers for high dynamic range, is already better than anything videographer can do, I think.
Yeah, so I don't think it's far off from, right now I can ask AI a question and it can mine articles and tell me the results of it can very, very efficiently sift through information, but it's probably not so far off where I can pose a question and it won't even waste time going into the articles. It'll just go into the data archive, run the analysis, and then give you the answer from the data, not going through this human step, which is...
Well, I think your involvement is going to be more in, with your expertise in the field, you can level with AI to give it instructions to some extent and give it moral guidance. I think that it will lack. Because I don't think you can come up with morality just through research and knowledge. It's more of a humane thing. You have to feel what's right and wrong or source it from religious text.
Yeah, I think empathic AI is not unobtainable.
You think it can realize morality on its own and what's right and wrong?
I mean, it has plenty to train on. I don't know. I have a hard time thinking that there's a limitation there.
Okay, let's say you're doing research, and in your research, you're going to stumble over some ants and wipe out a colony. But for the greater good, is it going to stop you doing your research?
The ants?
Yeah.
Oh, right. Yeah, you step on the ants to do the research.
Yeah, you would. You wouldn't even think twice. Let's say it gets on a scale where, in a comparison, we are ants. And where does the morality come?
Right. This is where the optimal solution of the multivariate optimization could be very stressful for us.
The most optimal state of the world is not to have humans.
Oh, I don't know.
I mean, we're contributing to.
We write pretty good jokes. I'm not sure if AI can have the timing of a stand-up comic. That's probably.
But we are
sometime.
contributing to global warming, aren't we?
And so will these very expensive processors that are keeping this AI alive. I mean, another thing the AI can't do is like drill holes until I guess maybe
Not
there's
yet.
drones and things. But like the what we can collect with data mining and satellites. I mean, it's a wealth of knowledge, but it is built on the backs of human efforts. And there's some things that are not in the Mark Zuckerberg's metasphere, right? Like there's some things that are tangibly essential to understand. Like we in glaciology, we're out drilling, taking ice cores and analyzing things, and I think it's some time off before AI has hardware as well as software.
No, I think it can happen so rapidly if it's learning on its own to a point where it can discover ways
Yeah.
to create new hardware that would bypass
Yeah.
all of the things that we can do through robotics. I mean, robotics already is so advanced. It's arguably not much left for us.
Well, we
I
better
think-
instate a universal basic income really quickly.
Yeah, that's going to be very
so
interesting.
the AI is trained on it to at least give us an allowance.
So let's go back to something you said earlier. You said there are ways to say stop or go back on global warming and sea level rising, besides just finding new alternative fuel sources. What are some other ways to level out temperature on Earth and make us a more habitable place long term? Because just on its own, even without human existence, things do change quite a bit. So are there actual hypothetical technologies that could stabilize things?
Like I think there's always proposing like a physical barrier around Lower Manhattan. It's like a buffer, like so if you can stop big storm surges from coming, and then this is one way. Yeah, again, there's things that you can, like aerosols and things you can put into outer space that change the albedo and can reflect more energy back to space. I'm not sure of many other like proactive human involvement, like ways to geoengineer out of climate change. It's a really massive problem. Like it's the scale of
What's like at the root of the problem? What's causing it? It's just we're putting more carbon into the atmosphere, right?
Yeah.
And then it's thinning out our atmosphere.
Oh, it's mostly the greenhouse effect. So when there's energy coming in, there's like the solar constant. There's energy coming in from outer space, and it either does one of three things. It either gets absorbed, reflected, or refracted. It kind of comes at an angle. And so a lot of energy is just sent right back to outer space in shortwave. And so so it comes in shortwave and it comes back as long wave. And so long wave, it penetrates through the atmosphere, penetrates through clouds, no problem. And then when it reflects, comes back as long wave, it either goes back to outer space or it hits things and then kind of does this back and forth and back and forth. And this is where it has this kind of warming effect. And so the more of these gases you have in the atmosphere, then the more of this effect you have. And the more you like this albedo, the more you shrink the ice of the Earth, then the more energy comes in and is absorbed by the ocean. And the ocean was quite interesting because it has a pretty massive tolerance for heat absorption. Like it can take a pretty good amount of abuse, but at some point, it's kind of like cod, right? When they were coming from Europe to United States, they were pulling cod out of the ocean. Like it was just like dinner was just like it was an unlimited dinner. Like just you could eat whatever. You could travel Europe, USA, no problem. Just pull the fish out of it. And then the cod were just depleted. And all of a sudden it was like, oh, this massive resource that we thought was limitless turns out has a limit.
So how is the water supposed to? I mean, if you're dumping more water into the ocean from ice, is it going to be better, or no?
So what it does is it freshens the ocean. It changes the salinity, and this can change the way that the ocean circulates because it's a different differential densities which creates the ocean circulation. So if you freshen up the ocean, you could have the potential to shut down the ocean currents, and then this
That would be catastrophic.
can be catastrophic. Yes.
Wow. At what point that could happen with current projections?
I don't think we know. I don't know.
What are some other crazy things that can happen? The volcano you said was talking to you
Yeah,
earlier.
mega volcanoes,
W-
like
in United
Yellowstone and
States,
things. Yeah.
and that's overdue.
I'm not sure. Also, magnetic pole reversals is a classic one in geology, like early geology classes. This is you just see these black stripe, white stripe, black stripe, white stripe. And there's quite a bit of a periodicity to it in geologic time, and you kind of look at, okay, well, what's happening for us? And it's like, all right, well, we've kind of been going pretty good for a while. Like, when's it gonna flip, and what causes the flip? And I think
We don't know yet.
I don't think it's very well understood what causes the reversals. But
And
I
if
think
it does reverse, that's like a cataclysmic event.
they correlate strongly with like massive extinction events. And
Wow.
it's just like, I think it's maybe like I think we think it's like a few 100 years, like something on a pretty fast. Geologically, it's like a second, but it's just like a period of instability where we are not like protecting ourselves from cosmic rays and things as well as we normally do.
I mean, like all these things can happen and will happen most likely at some point in time.
Yep.
I think humanity is reaching this interesting point where we're starting to understand what's about to hit us, and we have to drastically maneuver to survive. And it's, I think, all coming together quite nicely with the advancement of technology. We might actually be able to figure out how to deal with these things. Let's say something happens like a massive volcano in 500 years, we figure out super volcano that's going to impact the entire Earth. We might actually be good in 500 years. Elon Musk developing technology to go to Mars for, move humanity, or some way we utilize AI to find a way to prevent it or just discover on our own. I don't know if we can prevent them. Is it possible to even prevent a massive super volcano eruption?
A friend of mine, a volcanologist at the AVO, was testifying. I believe he was testifying in front of Congress, and some politician asked him if he was trying to get funding for the Alaska Volcano Observatory, and the question was like, can't we just stop a volcano from erupting? And I think without missing a beat, he said this only happened one time in history, and it was Mickey Mouse. And it's just like a cartoon episode where Mickey Mouse was like put his thumb in a volcano or something. But I think it's the scale is to this point beyond our capabilities.
And I just happen to think that God exists, and He's not going to let that happen, hopefully. There have been, at least biblically, a couple of extinction events.
Yeah.
But I think that's where we have to truly have faith that there's better life, better future. And it's somewhat in our hands, and probably more to do with morality rather than just advancement of technology. Because, like, let's say, going to just by the biblical story, they didn't cause global warming where a flood came in and swept everybody away. They corrupted themselves morally. And then God used the forces of nature to restore the order in the world. Perhaps there is this force in the entire planet that's observing and impacting the changes. I mean, not perhaps. At least I believe that with certainty that's how it is. I've even had conversations with AI, like, what are the odds of this universe existing on its own accord? And it's like 0. There's no chance that it's on its own. Absolutely none. The further back you look, or the greater data that you're going to look at, it's almost always you see that it's by design. And I think actually probably within your field, the further it's going to evolve, people will realize that everything is not just functioning on autopilot. There's origin and there's purpose. I don't know if you see this already. Do you see anything like that in glaciology, for example?
I think
Some kind of order that seems more engineered.
I mean, the things like the E, like the natural log, these pies and like these values that are sort of these global constants. It does kind of, at least to me, it feels a lot like when I initialize a model and you're just setting your constants. It's like you just plug in, maybe Hashem plugged in 3 and then there's a little disruption and okay, so it's not an integer anymore. Now it's this number. But like so there is some interesting, like the elegance of physical these equations that define so much in our and in thermodynamics and things. It's quite elegant. Um,
Does it seem like Earth has been designed for human habitation? Like, look at, especially, you roll back 100 million years, right? Was it habitable 100 million years ago? Or
yeah, probably.
it was?
For human, there wasn't the composition of the atmosphere was different. I think this is why the dinosaurs were so big. Why don't we have such big animals? We have whales, but they're in the ocean. They're kind of in their own thing. Like dinosaurs are so big because I think they needed really big organs to deal with the lower concentrations of oxygen in the atmosphere. Something like that. Like the physical creature needed to be bigger to accommodate the environment.
So
at
in
the
the
time.
grand scheme of things, you could argue like
It was not. It was
just
for who
our
we are
time
now.
frame
We're
to exist is very short.
Yeah.
Right? And it's almost as if it has been designed for habitation. But people can argue just by chance out of however many stars out there, 10 to the 21st power, whatever they say, there's bound to be one planet that just works out perfectly. But I think there's just so much more to it that even with all those chances, it's literally impossible. It had to be engineered and designed for a specific species to exist with a specific set of intelligence that can comprehend this. And I think we're introducing a new intelligence into the world that will help us discover this even further.
Well, I don't know. Like to me, there's a lot of parallels between a programmer and Torah, right? How do we start Bereshis? This is the beginning of the first word of the Torah. How does every programmer's career begin with print, hello world, close parentheses? It's like the beginning of a program.
Yeah, it certainly seems that way. Especially like with all the laws of nature just aligning together from macro to micro. It's all flowing perfectly together. I don't know. I think we need to research that more than anything else. Especially like with all the new tools available. I don't know why people are not focusing on that. Discover the source code of the universe. You know what I mean?
It's just it's kind of the beauty of the world that I live in two very polar. I study Gemara in the morning, and then I come and study modern science texts during the day. It's like these two canons of knowledge, and I think it's both an uncomfortable but also an extremely interesting two worlds to have 2 feet in, 1 foot each in.
But I think they're more or less intertwining now more than ever. With more access to information, I think we can look at the wisdom of the past and see some things that we didn't see before.
You or other?
In general.
Say more.
Yeah, even for example, like the number of stars in the universe, it's often believed, like the way it's been described in the Talmud, it's more philosophical. There's actually a passage that describes how many stars it could be, and if you add the numbers up, it's like 10 to the 18th power, a number that to a human being on an observable, in an observable sky, absolutely impossible to even fathom that number. But yet now, with all the advancement of telescopes, we can actually come close to it. It's a little bit maybe more or less. I think now they're saying 10 to the 21st power, but 10 to the 18th to 10 to 21st, there's some margin of error that can be tolerated versus 5,000 stars I see in the sky, 2,000 stars. Like those numbers don't align in any way, shape, or form. You can't make an error to say it's 5,000. No, it's 10 to the 18th power. Those numbers are nowhere near close enough. And there's so many other things, like within Kabbalah, that talks about the way universe contracts and expands. And even in the Talmud, you go back, they're describing at the edge of the universe, there's this green line. You can correlate it to so many things, maybe like microwave radiation that we're starting to see. You know what I mean?
I love it.
You got to go really deep into the text and apply scientific mind with an open mind. Sure, you will not have people from 2,000 years ago describing things on a level that you and I can understand because they just don't have those points of references that we have now. The same terminology. Well, we're out of battery life over there. So, anyways, it's a good time to end, but I think we have to go to Minyan anyways. I think we should continue this topic
I love
more
it.
specifically.
Beautiful.
Yeah. Thank you for joining.
It's been an absolute pleasure.
Thank you.
Of course.